guys, welcome to the Level 2 Calculus 2017 exam worked answers. So the way this paper works, well, this video works, is that I usually put a question up, pause the video, try the question by yourself, see how far you can go with this question. Now, I do apologize in advance because I believe by the time I finished recording this video, I had numerous interruptions, but I also had numerous locations where I filmed this. So my volume between each question might go up and down. So yeah, apologies in advance, but here goes. Okay guys, I'm going to go through this question right now. So in this question, you've been given a function and then you're asked to find the gradient of the graph at the point where x equals to 1. So I've already got the function. I'm just going to write it down as this. So f of x is x to the power of 5 plus 3x squared minus 7x plus 2. One good thing that you can actually do before you start any question is write down all the information that you have. So in this case, I've got f of x, and then write down what you need to actually try and work out. Now you're looking for the gradient when x equals to 1. So that means you're looking for f dash of 1. So before you get to f dash of 1, you actually need to figure out what f dash of x is first. So that's what I'm going to do here. So f dash of x is going to be 5x to the power of 4 plus 6x minus 7, and in the next step I need to substitute the 1 in there. So I've got 5 times 1 to the power of 4 plus 6 times 1 minus 7. I've got 5 and 6 minus 7. Your answer should be 4. So for this one, this is actually worth an achieved grade. Okay, let's go to the next question. Alright, so with this question, what you've been asked to do is find the equation of the tangent to the graph of the function. Now you've been given f of x, so that means we write down what we have. We've got f of x, but we actually need to find the equation of the tangent. To get an equation of a straight line, we actually need y equals to mx plus c. The thing is, right now we actually have got y and x, because x is actually 2 and then y is 18. We've got that. But what we do need is we actually need what the gradient is at point 2. So what we're looking for is we actually need to find f dash of 2. But to get to f dash of 2, we actually need to work out what f dash of x is first. So as usual, I write down my function, which is 6 14x minus 2x cubed, and then I differentiate it. So I'm going to get f dash of x equals 14 minus 6x squared. Next thing is trying to work out what the gradient at 2 is. So f dash of 2 equals 14 minus 6 times 2 squared, which ends up being minus 10. So if you guys actually have got up to this point right here, if you find the derivative and found the gradient, this actually gets you an achieved. But if you wanted to carry on and actually work out the equation of the tangent, which is what I'm going to show next. So let's go back and have a look. We've already got what y and x is, because the point that we're looking at is 2 and 18. We also know what the gradient is, which is equal to negative 10. So we need to actually write this as an equation to work out what c is. So I'm going to put down y equals mx plus c, and I can see that y is equal to 18 equals m is negative 10 multiplied by x is equal to, what do we got? X is equal to 2, and then plus c. So what I end up with is 18 equals negative 20 plus c. So c is equal to 18 plus 20, which means c is equal to 38. Now remember, it's actually asked you to find the equation. So if you just leave it c equals to 38, that's actually not good enough. Okay, so you got to write at the end of it that the equation of tangent is minus 10x plus 38. And if you can get up to here, you are looking at a merit for this question. Okay, so for this question here, what you have is you got some object that it's got a velocity that's been given as a function. It's saying basically to find how long it takes to reach an acceleration of 2.8. All right. So remember that with kinematics, you have those 3 letters. You've got S, you've got V, and you've got A. If you want to go from velocity to acceleration, you actually needed to differentiate. All right. So here we know what the velocity is. The velocity is 0.5 t squared minus 2t plus 1. So if you want to find the acceleration, you need to differentiate this. Differentiate velocity. So when you differentiate velocity, you got 0.5 times 2, that's 1. So it's 1t minus 2. So just differentiating that gets you an achieved. Okay? But if you go back to the question is asking you at what time is the acceleration 2.8. So we're actually saying that acceleration of t equals to 2.8, and we actually want to figure out what t is. So that means we write down 2.8 is equal to t minus 2, and then we rearrange this as t equals to 2.8 plus 2, and so your answer ends up being t equals 4.8 seconds. And folks, that gets you a merit here. Okay, so for this particular question, what we have is we've got tangent to the graph of a function. So let me just draw it a quick diagram just to see what's happening. So 3x squared minus 4x is a parabola. So it's a parabola that looks like this. Now it says that it has a gradient of positive 2, so that means probably the tangent is somewhere there. And then it says that it passes through the point 5a where a is a constant. So that means that line is actually going through 5a. Okay, so let's write down what we have. We've got f of x. We need to figure out f dash of x. We know that f dash of x at some point is going to equal 2. And that's all we have right now. Okay, so what we could do is, I'm going to work out what f dash of x is first. So I write down f of x, which is 3x squared minus 4x. I differentiate it, which means I end up with 6x minus 4. Now I need to figure out at what point is this gradient 2. So I'm going to put 2 equals to 6x minus 4, which means I end up with 6x is equal to 2 plus 4, and then 6 is equal to 6x. Then I can say x is equal to 1. So this x that is equal to 1 is basically this point right here. I'm going to put the little orange marker there. So that's this point right here. That is what 1 is. I don't know what the y value is, but I can actually find what the y value is by putting it in f of x, the original f of x. So f of x, remember that it's equal to 3x squared minus 4x. So if I put f of 1, then f of 1 is equal to 3 of 1 squared minus 4 times 1. So I'm going to end up with 3 minus 4, which means f of 1 is equal to negative 1. So what I've just discovered is when x equals to 1, the y value is negative 1. So that's right there. Let me just write that up a little bit clearer. So I've got the 1 there, and then I've got negative 1 here. So this is where I've got up to so far. How do I figure out the value of a? Now remember, the purple line here, the purple line has a gradient of 2. We already know that because that's what we got from the original question. And also with the purple line, we've actually got 2 points. The first point being 1, negative 1, and the second point being 5a. Now if you remember, the equation of a gradient could be written as y2 minus y1 divided by x2 minus x1. So what I'm going to do is I'm going to write this point here as x1, this point here as y1, x2, and y2. And now it's just a matter of substituting because m is equal to 2, so I can put that as 2. y2 is a, y1 is negative 1, divided by x2 is 5, x1 is 1. So simplifying this, I'm going to get 2 equals a plus 1 divided by 5 minus 1, which is 4, and then cross multiplying, I get 2 times 4 is equal to a plus 1. Carrying on, I've got 8 is equal to a plus 1, which means a is equal to 8 minus 1, and I end up with a is equal to 7. And that is basically it, guys, for this little question here. So in terms of grades, finding the a value gets you an excellence. Correct y coordinate found for the original function, so that's right here. That gets you a merit. For achieved derivative to an x coordinate calculated, so that would be here, is what gets you an achieved. Okay, let's go to the next question. All right, so for this question here, what we have is we've got a function, and it says that it has a turning point when x equals -1 and 3. So if it has a turning point, that means the gradient is actually equal to 0. So what we can say is f dash of -1 is equal to 0, and f dash of 3 is equal to 0. So the first step I'm going to do is I'm going to write down my function, which is x cubed plus ax squared plus bx plus 2. Now the question is asking you to find a and b. That means I've got two turning points. This most likely is going to be a simultaneous equation, but let's see what happens. So f dash of x would then be 3x squared plus 2ax plus b. Okay, so we got that so far. Now the next step is that we're going to use those two equations. My first equation is this one here. F dash of -1 is equal to 0. So that means I can actually write down 0 equals 3 multiplied by -1 squared plus 2a times -1 plus b. And when I do this, I end up with 0 is equal to 3 times -1 squared is 3. 2 times -1 times a is -2a plus b is equal to 3. All right. And so what you can do is, that's one equation. Our second equation here is f dash of 3 is equal to 0. So then what I could do is I can write down the same equation. So 0 is equal to 3 times 3 squared plus 2a times 3 plus b. And what I end up with is 0 is equal to 3 squared is 9 times 3 is 27 plus 6a plus b. Okay, now here's the neat thing. You've actually got two equations with a and b, which means you're dealing with simultaneous equations. And I'm going to show you guys with this particular question. You would have done so many different ways of simultaneous equations last year. You would have had elimination, substitution, and whatever the other one is that I can't remember at the moment. What do we got? Substitution and rearranging. In this particular one, I'm going to actually see how both equations have a b by itself, and they both equal to 0. In this particular one, I can do this. I can actually put this equation 1 and equation 2 equal to each other, because there's 0 on both sides and there's a single b on both of the equations as well. Because what it will look like is, it'll look like this: 3 minus 2a plus b equals to 0. And remember, the second equation equals to 0 as well. So I can write that as 27 plus 6a plus b. Now the reason I can do this, as I've told you guys before, is that both equations have a single b, which means I can just eliminate both of the b's, and I'm left with a nice simple linear equation where I've got 3 minus 2a equals 27 plus 6a. And rearranging this, I'm going to get 3 minus 27 equals 6a plus 2a. So I've got 8a equals -24, and then a equals -24 divided by 8, which means a is equal to -3. Now I figured out what a is. Now I need to go back and substitute in either equation 1 or 2 to try and figure out what b is. All right, so I'm going to use equation 1. So that's 0 is equal to 3 minus 2 times a plus b. I'm going to get 0 equals 3 minus 2 times -3 plus b. And I'm getting 0 equals 3. What have we got? Minus 2 minus 3 is plus 6 plus b. So rearranging it, I'm going to get 0 equals 9 plus b. B is equal to -9. And there's my two answers for a and b. So finding a and b gets you an excellence. Gradient functions, so that would be somewhere here, is getting a merit. So when you substitute the gradient equal to 0 and the corresponding x values, I think if you just find derivative and equate it to 0 at some point here, you could be looking at and achieved for this question. Okay, let's move on to the next question. Okay, so this is what I'm going to do again with this question. So first step is this. that's my turning point right there. All right, my turning point is at 0.5. So that means on my gradient function, sorry, that should be negative 0.5. At negative 0.5 is where this derived function is actually going to cross. As I said earlier, like this shape right here, it's a parabola, but it's a negative parabola. So that means I can say f of x is negative x squared. But when I differentiate it, it's going to become negative 2x. Okay? So, and because of that, on this side of it, on the right hand side, I've got to draw a straight line that's going to go through negative 0.5. And I know my straight line is very ugly, but just when you guys draw it, just make sure you use a ruler. All right? But you got to make sure it's roughly negative 2. Okay? Please don't do this. Just because it has a gradient going through there, don't end up drawing like something like this, because that's not negative 2. That's actually far less. Like that gradient is not as steep as the blue line has a much steeper one compared to the purple one. Okay, so be careful with that one. So basically that's all that is for this particular question. My advice for you guys is that always first step is look where the turning point is. Second step is come up with a rough equation. Third step, differentiate it. Fourth step is sketch the line. And if you do that, that's basically an achieve for this question. All right, so for this question, we've got f of x equals 2x cubed plus bx squared minus 2. As usual, turning point means m equals 0 at x equals to negative 1. So we know that f dash of negative 1 is equal to 0. So we got f dash of x equals 6x squared plus 2bx. We know that f dash of negative 1 is equal to 0. So we can say that 0 equals 6 times negative 1 squared plus 2 times b times negative 1. So 0 equals 6 minus 2b. Rearranging this, we're going to get positive 2b is equal to 6. And then b is equal to 6 divided by 2. Therefore, b is equal to 3. Now, just in terms of what you get for grades, derivative found and equated to 0. So just getting it up to here is an achieved. And then solving it, which is value of b found, is a merit. Okay, so for this question here, it's asking us basically to show that this line is a tangent to the graph of this function, right? So one thing I like to do is like just do a quick sketch. This is a parabola. So that means it's going to look like this. And then we've got a straight line here with a gradient of positive 15. Because it's positive 15, it's going to be on this side of the parabola. And it's going to look something like this. All right, with a gradient of 15. So the first thing I'm going to do is find out at what's the x value here when the gradient is equal to 15. So I've got the function here. The function is 4x squared minus x plus 4. And I'm going to differentiate this to get my f dash of x, which is 8x minus 1. And because I know the gradient is equal to 15, I'm going to put 15 equals to 8x minus 1. And rearranging this, I've got 15 plus 1 equals 8x. And then 16 equals 8x. And then x is equal to 16 over 8. Therefore, x is equal to 2. So what I have right now is the x value. So if I want to prove that this purple line here is actually a tangent to the green parabola, then I'm going to color this red here. The red point, which has a coordinate of x and y, should be the same for both equations. So if I put 2 in the purple line, I should get the same y value as if I put 2 for the green function as well. So I'm going to do the purple one first, because the purple one is y equals 15x minus 12. And if I substitute 2 in there, I'm going to get 15 times 2 minus 12, which equals to 30. Take away 12, and I've got y is equal to 18. The next thing is I want to repeat the process, but this time for the parabola. So for the parabola, I've got 4x squared minus x plus 4. which means I'm substituting 2 because I'm trying to figure out what f of 2 is. So that's going to be 4 times 2 squared minus 2 plus 4. I've got 4 times 4 is 16 minus 2 plus 4. This is equal to 18. So from here I can see the purple line goes through 2 and 18, and the green parabola also goes through 2 and 18. And so I can basically say, because of this, what can I say? Line is tangent to parabola at 218. All right, basically we've actually proved that the point, both of those graphs actually go through that point 218. So in terms of grades, for achieved, I think derivative finance set to 15, just here. That gets you an achieved, and I think the final part here gets you a merit. Okay guys, on to the next question. So with this question here, what we have is we've got a line, y equals 6x plus k, and we need to figure out what k is if it has a function of x squared plus 2x minus 1. Okay, so what we know is we can actually, from f of x, we can actually work out f dash of x. All right, now it has a tangent of y equals 6x plus k, which means that gradient at this point is equal to 6. Okay, so we need to figure out what that x and y is, and once we figure out what that x and y is, then we can substitute it into the tangent equation to figure out what k is. Now, I know it might seem a bit crazy, but let's just bear with me on this one. All right, so first step is work out f dash of x. X squared will convert to 2x. 2x will convert to 2. Now, at this point, we need to actually figure out what at what point of x is the gradient 6 equal to, or 6 is. So we can say 6 is equal to 2x plus 2. Let me just show you guys what I mean by. So because we've got x squared, right, it's a parabola. All right, now we've got a tangent at when the gradient is 6. Now this purple line here is it's y equals to 6x plus k. All right, and the black line, the black is the parabola, and of course I'm going to put this point right here, green, that green point. So I need to actually figure out what the green point is first to actually work out k. Okay, so what I know is the gradient at that point is 6, and that's what I'm doing here on the left hand side. So rearranging this, I'm going to get 6. I've got 6 minus 2 equals to 2x, which is 4, and then 2x equals 4, so x is equal to 4 divided by 2. We can say therefore x is equal to 2. So what I've discovered right now is this point right here on the green dot, the x value is 2. I need to figure out what the y value is, and to do that I can substitute it into the black parabola. All right, now remember the black parabola's equation is f of x is x squared plus 2x minus 1. So I'm trying to figure out what f of 2 is. So that means this is going to be 2 squared plus 2 times 2 minus 1, which equals to 4 plus 4 minus 1, which is equal to 7. Now this 7 right here is the y coordinate of the green point. So now that I have the green point, which is 2, 7, it's also, that point is also on the purple line. So using, what I can do is I can use the point 2, 7 with the purple equation, which is y equals to 6x plus k, and I can actually figure out what k is, because in this case y is equal to 7, and then x is equal to 2, and k is there by itself. So I've got 7 is equal to 12 plus k, so then k equals 7 minus 12, and in the end I can say k equals to negative 5. Alright guys, so with that in mind, this final part is equal to excellence. X and y found, so if you've actually found the point, the green point, it's going to be merit. Derivative found and equal to and set to 6. So this part here is actually what achieved. Okay, hopefully this question made sense. We go on to the next question. Okay, so this question here, what we have to do is we've got to actually prove that this graph has a local maximum when x equals to 9/4. Okay, and then we've got to justify that it's a local maximum as well. So the first thing I'm going to do is I'm going to actually write down f of x, which is x cubed multiplied by 3 minus x. Now, because it's being multiplied, we don't really know how to differentiate this yet. But next year in year 13, you will actually learn how to do this. But for now, what we're going to do is we're going to expand the brackets, and we're going to get 3x cubed minus x to the power of 4. So that's what f of x is, which means f dash of x is equal to 9x squared minus 4x cubed. Now remember that we're trying to prove that it has a local maximum. If it's first off, if it's a maximum or a minimum, I'm just going to write here max or minimum, then we know that the gradient has to equal 0. So I'm going to put down 0 equals 9x squared minus 4x cubed. Now, really important, guys, that you don't actually take 4x cubed to the other side and cancel x out, because that usually means that you'll miss out an answer. It's best to factorize this. So x squared is a common factor. I can take x squared out and I'm left over with 9 minus 4x. Okay, so what we have is we've either got x squared is equal to 0 or 9 minus 4x is equal to 0. Now with x squared equals to 0, x is equal to 0. And then with 9 minus 4x, we've got negative 4x equals negative 9, and x equals to negative 9 divided by negative 4, which means x is equal to 9/4. Now at this point, you've got the 2 points where it could be, one of them could be local maximum or local minimum. Now it says justify that the turning point is a local maximum. Now I don't know if you guys have actually done this before, but what you could do is you could actually work out the second derivative. So what I'm talking about second derivative is you've got f dash of x, then you differentiate it one more time. So you get f double dash of x. Now f double dash of x is you've got 9x squared differentiates to 18x, and then minus 4x cubed differentiates to minus 12x squared. Okay? And then what we can do is we can actually substitute f double dash of 0. So if I do f double dash of 0, I end up with 18 times 0 minus 12 times 0 squared, and I end up with a 0. So this is, this is not maximum, because remember, for maximum, f double dash of x has to be less than 0 if it is a maximum point. So I'm going to try f double dash of 9/4, which is 18 times 9/4 minus 12 times 9/4 squared, which gives me an answer of negative 20.25. And if you think about it, because f double dash of x is less than 0, we can actually say, therefore, not therefore, sorry guys, we can actually say f double dash of 9/4 is less than 0, therefore this is a local maximum point. Cool, and that's basically it for this question. So this part right here gets you to an excellence, cubic equation solved, so this part gets you to a merit, derivative found, which is right here. This line up to this line gets you an achieve. All right guys, let's go to the next question. So in this question, you've actually been given the gradient function. All right, so you've actually been given f dash of x. You're also given the point 1, 3. So we know that f of 1 is equal to 3. And we're asked to figure out what f of x is. So we've got our f dash of x. I'm going to write that down as usual. 6x squared minus 2x plus 4. So I need to integrate this to get my f of x, which means I'm going to get 6x cubed over 3 minus 2x squared over 2 plus 4x plus c. So simplifying this, I have f of x is equal to 2x cubed minus x squared plus 4x plus c. And to figure out what c is, I need to substitute f of 1, 3. So I'm going to end up with 3 equals 2 times 1 cubed minus 1 squared plus 4 times 1 plus c. So I've got 3 is equal to, what do we got? 2 minus 1 plus 4 plus c. And so rewriting this, I've got 3 equals 6 minus 1 is 5 plus c. Therefore, c is equal to minus 2. Again, can't leave your answer there. You've got to write your full equation, which means y equals to 2x cubed minus x squared plus 4x minus 2. And yeah, that's what you need to do for an achieved for this question. So if you guys have a look at this, the first important thing to notice is that you've actually been given f dash of x, and you need to figure out or draw f of x. So looking at the equation of this particular graph here, we know it's a parabola. All right, don't care about the rest of those terms. I just want to look at what type of parabola is it. It's a positive parabola. Now, if I integrate x squared, I end up with x cubed over 3. Okay, so I know that when I draw the graph for this parabola, the integrated version, it's going to look something like this because that's a cubic. Okay, now let's actually go back and try and figure out the most important key points. The first key point is here in your equation. Sorry, not equation, in the question. It says the point 0, 0 is on the graph of the function y equals f of x. So that means this cubic is actually going through 0, 0. Okay? And you have to make sure it goes through 0, 0. That's the first clue that you get. The second clue is we've got a maximum point there and we've got a minimum point there. Remember that at this point the gradient is 0 and at this point the gradient is 0. And we can actually see that right here and here, I'm going to choose a different color, give me a second. Right here, this one the gradient is 0 and this one the gradient is also 0. That's at -2 and that's at roughly, I don't know, I'm going to call it 1.5. All right, so that means your cubic, just to give you a rough idea, your cubic could look like this, but what we need to know is that at -2 there's a maximum and at -1.5 there's a minimum. So your cubic could look like this. All right, as long as it, that's sucky. So it's got to go maximum there, got to go through 0, 0, and then come out there as a minimum there. That's one version of this graph. You could also have another version of this graph. I mean, these are sketches, remember that. So you could have another version where it looks like this. But the key thing is that it has to go through those 3 points. So I could end up with a cubic that looks like this. But the important things that they'll look for is your graph going through 0, 0? Is your maximum at -2? And is your minimum at 1.5? So people could actually draw the blue graph or the purple graph, and either one of them you could actually get it correct, as long as the maximum and minimum is aligned with -2 and +1.5, and the cubic has to go through 0, 0. Because if you can do that, that ends up being a merit. But if it's just a positive cubic graph going through 0, 0, then it's an achieved. So when you have a question like this where it says object has a constant acceleration of -4, so the first thing we can write down is that a equals to -4. Next thing is this, and I think the most important thing to look at is when recording of the object motion begins. So that means it's when t equals to 0, it's 12 meters from P, so we can then say S of 0 equals to 12. It's moving away from P, so don't worry about that too much. Has a velocity of 6, so then we know that V of 0 equals to 6 as well. So now if we go to the question's actually asking what the velocity is after 5 seconds. Now, we know what acceleration is. So acceleration is equal to -4. Then we know that velocity equals integral of acceleration given time. All right. So now you don't need to write this particular format here. you can straight away just go write down velocity as negative 4t plus c, because when you integrate acceleration, you get velocity. But here's the thing. You know that velocity of at 0 seconds is equal to 6. So we can actually say that if v of 0 equals to 6, then 6 is equal to negative 4, but it won't be t, it'll be 4 times 0 plus c. Therefore, c is equal to 6. So what we have is we've got the velocity formula. So v of t equals negative 4t plus 6. So this part gets you an achieved. And carrying on with this question, to actually find out the speed after 5 seconds, we're looking for v of 5. So that's going to be negative 4 times 5 plus 6, which equals to negative 14. And the units in this case is centimeter per second. So just getting up to 14 here can actually get you a merit. So remember that with these types of questions, write down the information that you have and kind of slowly start working backwards as to what you need to actually find out. So this is just basically a follow-on from the previous question. So things that we already know is we know that s of 0 equals to 12. And we also know from the previous question that the velocity could be written as negative 4t plus 6. Now the question's asking you what's the maximum distance. That's the first part. And then the second part is justify that this is a maximum distance. So if the velocity equals negative 4t plus 6, then s of t, which is the distance, I've actually got to integrate the function. So if I integrate this, I get negative 4t squared over 2 plus 6t plus c. And when I simplify this, I get negative 2t squared plus 6t plus c. All right, now remember that s of 0 equals to 12. So that means I can substitute this as 12 equals minus 2 times 0 squared plus 6 times 0 plus c. Because everything is 0 on that side, I can literally say 12 equals to c. So now I have the function of distance, which is negative 2t squared plus 6t plus 12. Now that's the first part. The second part it's asking you is find the maximum distance. For you to have maximum distance, you actually need to put velocity is equal to 0, because when the velocity is 0, that's when it's reached its maximum distance. I don't need to differentiate this function, the s of t, because if I differentiate it, I'm actually going to end up with velocity which equals negative 4t plus 6. So at this point I can say 0 equals negative 4t plus 6, and what ends up happening is I got 4t equals to 6, t equals to 6 over 4, so t equals to 1.5 seconds. So at 1.5 seconds, that's when the maximum distance is actually happening. So I substitute 1.5 seconds into s of t to figure out what the maximum distance is. So I've got 1.5 there. I'm actually going to substitute s of 1.5 and figure out what that distance is. So I'm going to get negative 2 times 1.5 squared plus 6 times 1.5 plus 12. Now when I solve this, I actually end up with 16.5 centimeters. All right, so that's what the maximum distance is. Now, to prove that this is going to be the maximum distance, what you could do is you could actually look at the function of s of t. Now, if you look at s of t is actually a negative parabola. All right. So negative parabola means the function of s of t, it's going to look like this, which means when the gradient is actually 0, that point right there is going to be a maximum point, and you just need to describe it either by drawing a graph and just saying that this is going to be a maximum point. That's one way of doing it. The second way of doing it is by actually mentioning the acceleration. Because the acceleration is, and I remember doing this at an earlier stage, but you can actually do this. If f double dash of x is less than 0, it's known as maximum. And in this case, because acceleration is less than 0, we can actually say that this is going to be the maximum distance. All right. So in terms of grades, you either need number 1 or number 2 here for an excellence grade. For merit, it is finding the value of s. So this is, if you can get up to here, it's a merit. And if you get an equation for s, you actually end up getting an achieved. Okay? But remember, this question actually mentions you to justify. So you have to actually prove that the point is maximum or minimum. In this case, it's going to be a maximum. All right, and we have our last problem for this particular paper. So what we have to do is we've got to find the maximum volume of the open box. The best way to go about this is that we're going to rewrite this corner here as, because I mean obviously they are corner squares. If they're corner squares, then we can say that this is going to be x and x, and that's going to be x, that's going to be x. Sorry, just bear with me. That's x and that's x. All right. But here's the thing. This little part here, this green part, because on the outside is 20 take away 2, because I'm looking at this part here. So that's 20, and then I'm getting rid of this x here, and I'm getting rid of this x here. So the green part here is going to be 20 minus 2x. And likewise, I'm going to have the orange part here. So 30 is the whole thing, and then I'm taking away this x. Oh, sorry, already written x there. And then I'm taking away this x. So the orange part here is going to be 30 minus 2x. So if you think about this as a cuboid, then the shape is going to look something like this, where your height of this cuboid is going to be x. Then one of the sides is going to be 20 minus 2x, and one of the other sides is going to be 30 minus 2x. And so we're asked to figure out what the maximum volume is. So we can say that volume is equal to base times height times length, depth, whatever it is that you want to call it. And I'm going to write down all my things. So one of my bases is 20 minus 2x multiplied by the height, which in this case is x, multiplied by the length, which in this case is 30 minus 2x. Now guys, it doesn't matter which order you go about it in this one, you're still going to end up with pretty much the same answer, because when you multiply 3 things, it just works out the way it is. I'm going to multiply these 2 first. So I've got 20x minus 2x squared, and then that's getting multiplied by 30 minus 2x. So I've got a quadratic. 20x times 30 is 600x. 20x times negative 2x is minus 40x squared. Then I've got these 2, which is equal to minus 60x squared plus 4x cubed. So this simplifies to 600x minus 100x squared plus 4x cubed. Now I need to differentiate this if I want to figure out what the maximum volume is. So when I differentiate 600x, I get 600. Take away 100x squared, differentiates to 200x squared. And then I've got 4x cubed, which differentiates to 12x squared. And I just realized what I made a mistake with. That should be 200x. Sorry, not 200x squared. Okay. Now remember, for the maximum volume, if you want to figure out a maximum of anything, you've got to differentiate it and equal to 0. So I'm going to put this equal to 0. 600 minus 200x plus 12x squared. Now at this point, guys, look, I'll be honest. You've got a graphics calculator. Use it. So put this in the graphics calculator quadratic solver, and what you should end up with is that x is equal to 12.742, or you should get 3.9237. Now at this point, we got to try and figure out what the volume is. And I guess the first thing to realize is that x actually can't be 12.742. Okay. Now you might be going, well, how did he figure that out so quickly? Because think about it. Just roughly, 12 times 2 is about 24, right? And one of your sides is actually only 20. So if, like, what I'm trying to say is, like, I'm running out of space here, but I'm going to try and do it right here. So if you actually go 20 minus 2x as one of your sides, then you got 20 minus 2 times 12.742, and that's going to end up with a negative, I don't know, 5 point something number. All right, now you can't have a side of negative 5 point something, so that's why x can't be 12.742. Sorry about that, excuse me. Okay, so sorry about the phone call, guys, but anyway, where were we? Okay, now we still haven't figured out what the maximum volume is. So to figure out what the maximum volume is, you need to substitute 3.9 as x. So that means you're going to get 20 minus 2 times 3.92 times 3.92, which is x, multiplied by 30 minus 2 times 3.92. And when you do this, you end up with an answer of 1056.3 centimeter cubed. Now, another thing that you need to be very careful about with this question is that it actually says in the question, justified that this is a maximum volume. A really quick way to actually do this is when you look at V dash, which is volume, the V dash formula is actually a parabola. Actually, let's not even look at that. Let's actually try and do V double dash, because that might be easier for you guys to work it. So if I do V double dash, what ends up happening is I get negative 200 plus 12x squared would become 24x. Okay, and now what I can do is substitute 3.9 in it. So I'll get V double dash equals negative 200 plus 24 times 3.92, whatever that is. And this ends up being negative 105 and 0.8. So at this point, you can actually say V double dash of 3.92 is less than 0. Therefore, it is a maximum point. Okay? All right, guys, that's basically it for this question. I'm sorry I ran out of space and for the phone call, but that's life. So excellence is for you to confirm that the x value is the maximum. So you do need to do this part here. Differentiated and x values found for turning points and volume found. So if you find the volume up to here, you get a merit, and the relationship formed and differentiation isn't achieved. So that's actually up to here. Cool. That's basically it for this question. Okay, guys, that's basically it for this long video. I do apologize because the video was actually taken in multiple locations. I mean, part of it was in my class, part of it was during lunchtime, and then at the end of the day. But hey, look, got to get these videos out for you guys, because I know there's mocks coming up. One piece of advice that I'd give you guys that are doing calculus is that majority of the time, you know, if you get stuck in a question, just differentiate and put it equal to 0, put it equal to whatever gradient's given, and that should kind of at least get you an achieved. Or sometimes if you're lucky enough, you might even be able to solve the problem into a merit. But hey, look, thank you for watching this video. If you have any questions, pop it in the comments below. And of course, don't forget to like, share, and subscribe this video.